Good morning, children. Okay. Today we are going to start with the last topic of the section, probability. Okay, last topic of the first term portion, normal distribution. Write the heading, normal distribution. Till now we have learned about Poisson distribution, binomial distribution and all we have learned. The next one we are going to learn is normal distribution. Okay, so normal distribution is an easy one. We have learned about normal curve in 11th standard. Okay, okay, little what, somewhat continuation of that part. Okay, a few things what you have learned in 11th standard we need here. So write the heading, normal distribution. Normal distribution. Okay, so before we start with the normal distribution, normal distribution. Before we start with normal distribution. Okay, so normal distribution, okay, is the previous two cases we have learned, binomial and Poisson are for discrete variables, isn't it? Then outcomes will discrete. For discrete variables only we discussed about binomial and Poisson. But here, normal distribution is for a continuous variable. Okay, it is for continuous. If the data is infinite, okay, whenever we consider a lot of variable values, suppose x takes a lot infinite values, in that case we define normal distribution. Okay, so all these points noted down, children. Okay, the previous cases and all for definite one. Okay, discrete one. Here, okay, note down all these points. It is non-discrete. These are all some 1 mark questions. Okay, it is non-discrete, or we can say it is continuous. Okay, this is the distribution. We define it for continuous variable. It can assume infinite values. That means this distribution can assume infinite values. It will assume infinite values. For example, you can take height of a people. Height of a people means so many people are there. So you can take 161, 162 like that. You will get infinite data. Okay, so some data may be repeated, but we take number of people and all, we take it as infinite. So it is widely used in statistics, and this is and this type of distribution we call it as continuous probability distribution. Continuous probability distribution. Okay, continuous distribution. Okay, now write the next heading, probability density function. Okay, I think you have the textbook. Is that no? All of you open your textbook. Okay, you can mark all those things in your probability distribution function. A continuous probability distribution function will satisfy few concepts. Okay, like what we say in discrete, probability of an event is greater than 1. Sum of all probabilities is 1. Like that, we give some properties. Same way, continuous distribution function will satisfy these conditions. What are the first? Okay, instead of summation, here we use the term integration. So first one is f of x is greater than or equal to 0. We say probability is greater than or equal to 0. Here, instead of that, we say that f of x is greater than or equal to 0. Second one, integral minus infinity to infinity. F of x dx is 1. Sum of all probabilities is 1. Here, it is an infinite data. So we take it as integration. Instead of summation, we use the notation integration. And the third one is, the third property is P of A less than or equal to X less than or equal to B. We want to find the probability of an event lying between A to B means it is integral A to B f of x dx. Integral A to B f of x dx. Okay. So this is about the properties of probability density function. Okay, suppose capital X is a continuous random variable. Suppose X is a continuous random variable. Then the probability distribution function will satisfy all these conditions. Okay, is it okay? Up to this, is it clear? Shall we move on to the next point? Is it okay, Aishwarya? Tomlin?
Yes, ma'am.
Now we can, okay, the next Right, the next one, normal distribution. The next is we are going to learn about normal distribution. So for normal distribution is an example for, it is one of the type for continuous distribution. Okay. One important continuous probability distribution is normal distribution or normal probability distribution function. Everything is same, normal distribution, normal probability distribution function, or it is otherwise called Gaussian distribution. It is otherwise called Gaussian distribution. Okay, it is otherwise called Gaussian distribution. Okay, and last year we have learned about the graph of curve of normal distribution. The curve of a normal distribution is like a bell-shaped curve. Can you recall this one? Last year we have learned it. Okay, so the curve will be a bell-shaped curve. Okay, write down this one, note down this. Okay, normal distribution curve is a bell-shaped curve. This function we have learned last year. Okay, the normal distribution curve is a bell-shaped curve. What are the features we have learned? It is bell-shaped. It is symmetrical. Symmetrical along the y-axis. Look at here. To the left, what we have, the same thing only we will have on the right side. And here, for a normal distribution, mean will be same as median is equal to mode. All the three are same. Mean is equal to, median is equal to mode. For a normal distribution, all the three things are same. The mean, median, mode, everything will coincide. So the normal distribution curve takes the form of bell-shaped curve. And for a normal distribution, mean is equal to, median is equal to mode. Mean is equal to, median is equal to mode. See, although this line, okay, look at this, it comes to down, it will not cross the x-axis. That is the thing you have to note. Okay, in a normal distribution, the curve, although it is coming very closer and closer to zero, it will never cross x-axis. Okay, up to this, is it okay? Is it clear? Next, we are going to learn about the probability distribution function. Write the heading, normal distribution function. Next, we are going to learn normal distribution function. See, the normal density function is given by the normal density function or normal distribution function is given by f of x is equal to f of x is equal to normal distribution function is given by normal distribution function is given by, note down children, it's a lengthy function. Okay, 1 by sigma root 2 pi. 1 by sigma root 2 pi e raised to minus 1 by 2 half into x minus mu by sigma the whole square. Okay, normal distribution function is given by f of x is equal to 1 by sigma root 2 pi e raised to minus half x minus mu by sigma the whole square. What is mu here? The usual notation itself. Mu is expected value of x. It is otherwise called mean. Okay. And variance of x is denoted by sigma, isn't it? Sigma square. It is denoted by sigma square. Variance of x is given by sigma square. Binomial function we denote like this, b of n comma p, isn't it? Binomial we denote a b of n comma p. If we know n and p, we can write. So likewise, a normal distribution is denoted by, a normal distribution will be given by capital N of mu comma sigma square. capital N of mu comma sigma square. Normal distribution is given by N of mu comma sigma square. Okay. So now if you give the normal distribution function, Aditya Satyan, normal distribution function is given by
mu comma sigma square.
and that is denoted by, okay, how will you define a normal distribution function? It is defined as f of x is equal to that function, normal distribution function or normal density function.
1 by sigma 2 pi e minus 1 by 2 x minus mu by sigma square.
Sigma the whole square. Okay, sigma the whole square. Yes, Aishwarya, once again repeat it. Give the normal distribution function.
1 by sigma root 2 pi e raised to minus 1 by 2 into x minus mu by sigma the whole square.
Okay, is it clear, children? Up to this concept, is it okay?
And can you show the slide once again? I was not able to complete.
Okay, write down.
Completed, ma'am.
Okay. Okay. So up to this point, is it clear, children? Not okay. Write down all these points. See, few points only are there in your textbook, in your reference book. Few points are not there. Whenever I give additional point, note it down. So up to this, is it clear? The normal distribution curve means it takes the form of a bell-shaped curve. Okay. It takes the shape bell-shaped curve. Okay. So here it is from minus infinity to infinity. Note down these points again here below for this, for a normal distribution curve. It has unique mode. Look at here, only one top value is there. So the given curve, here it will get the mode. It has unique mode. Only one mode is there. The bell-shaped curve has one peak. That means normal distribution has unique mode. The normal distribution has unique mode. For a normal distribution, mean, median, mode are the same. Next one. Next point. What is the next point we wrote? Okay, that one I think we discussed it earlier. Anyhow, write down the third point. The curve will never cross x-axis. It will never touch the x-axis. If it touches only, it will cross. Is that no? So this curve, write down the point, next point. The curve extends on both sides. The curve extends on both sides, but and never touch the x-axis. It will never touch the x-axis. It will never touch the x-axis. It will never touch the x-axis. Next one, this line, okay, this symmetric line. The symmetric line, the line, write down the next one, x is equal to mu. The line x is equal to mu divides the normal curve. The line x is equal to mu divides the normal curve into two parts. The line x is equal to mu divides the normal curve into two equal parts. It divides it into two equal parts. So the next point is, so the normal curve is symmetrical about. Therefore, the normal curve is symmetrical about. The normal curve is symmetrical about x is equal to mu. Next one is the total area under the curve. The total area under the curve is minus infinity to infinity. F of x dx will be equivalent to 1. The total area under the curve is 1. So these are the features of normal distribution. These are the features of normal distribution. Okay. So suppose we have so many data. Suppose in one data you have mean 50 and variance 30. In other data I have mean as 20, variance is 5. How to compare? For comparing all those things, we are going to learn another normal distribution. That one we call it as standard normal distribution. Write the next heading, standard normal distribution. For the purpose of comparison and all, we use another distribution. That one we call it as standard normal distribution. Okay. Standard normal distribution. Write the heading, standard normal distribution. Standard normal distribution. Okay, why we define this? Okay, to all the normal distributions can be compared if you make it into standard. If you make it into standard, we can compare it. Okay, so before that, what is the normal distribution? Once again, give me the normal distribution. The normal distribution is given by f of x is equal to, normal distribution is given by f of x is equal to 1 by, what is the formula? 1 by sigma root 2 pi e raised to minus half into x minus mu by sigma the whole square. Listen, all of you, listen children, listen. So this is the normal distribution. So in the normal distribution, you put sigma is equal to 1 and mu is equal to 0. A normal distribution with mean 0 and sigma is 1 will become a standard normal distribution. Is it clear? A normal distribution with sigma is 1 and mu is equal to 0 is called a standard normal distribution. And the standard normal distribution, it is otherwise called Z distribution. Z. Okay, look at this format we write. It is called Z distribution. Standard normal distribution. Okay, this is otherwise called Z distribution. Okay, listen children, 1 second, don't write, listen. So when you put sigma is equal to 1 and mu is equal to 0, what happens? What will be f of x? F of x will become 1 by root 2 pi e raised to minus half. What you will get? E raised to minus half into this one will become x square by sigma square. X square by sigma will become 1, isn't it? Minus. So minus x square by 2. But listen children, whenever it is normal distribution, for a normal distribution, instead of x, we use the variable z. That is why we call this a Z distribution or Z distribution. So it is always denoted by f of z. Normal distribution is given by, standard normal distribution is given by f of z is equal to 1 by root 2 pi e raised to minus z square by 2, where minus infinity less than z less than infinity. So this is the distribution of standard normal distribution. Standard normal distribution, it is otherwise called Z distribution. It is otherwise called Z distribution. It is otherwise called Z distribution. Is it okay, children? Note down all these points. These terms and all is not there. Okay, Z distribution or Z distribution means when we transform a normal distribution to standard normal distribution. Okay, instead of x, we use the variable z there. Okay, instead of x, we use the variable z. When mu becomes 0 and sigma becomes 1. F of z is 1 by root 2 pi e raised to minus z square by 2 is called the standard normal distribution. So In order to convert, listen children, look at the next point. Okay, all these points are very important. That is why going on insisting, note down, listen. Okay, listen. So to convert normal to standard, listen, it is for your understanding. To convert normal to standard, we put x minus mu by sigma as z. Okay, we can substitute this one. We put z is equal to x minus mu by sigma. And this term only we call it as z score. It is called z score. X minus mu by sigma. In the place of x minus mu by sigma, we are writing as z, isn't it? So it is called z score. Okay. In the normal distribution, if you put x minus mu by as sigma as z, it will become standard normal distribution. So x minus mu by sigma is called the z score. It is called the z score. Okay. Next heading, area under standard normal curve. Next heading is area under standard normal curve. Area under standard normal curve. So listen, all of you can write afterwards. It is in your textbook. All of you take your page number 386. You can mark it in your textbook itself. So, okay, then listen children, listen all of you. So the standard normal distribution is given by f of z is equal to 1 by root 2 pi e raised to minus z square by 2. What about z? Z varies from plus infinity to minus infinity. Minus infinity to plus infinity. Now listen, the first thing we are going to define is cumulative. What is meant by cumulative? You have learned this one in mean, median and all. What is meant by cumulative? Cumulative. What is the meaning of cumulative? Summation, adding, total. Okay, we used to add cumulative frequency. Cumulative frequency means what we used to do, we add the frequencies. Similarly here, cumulative distribution function. We define cumulative distribution function. Cumulative means what? We add up. So cumulative distribution function is denoted by, look at the notation, capital F of Z. Capital F of Z is, we have to add. Here, adding means it is a continuous distribution, so we have to integrate. So it is minus infinity to Z. Minus infinity to Z, 1 by root 2 pi e raised to minus z square by 2 into dz. And same function, when we add up, cumulative means we add it. We add up this one. Cumulative means adding up all the frequencies. So adding up of the distribution. F of z is equal to minus infinity to z, 1 by root 2 pi e raised to minus z square by 2 into dz. Okay. The curve, look at here. The curve function will be given like this here. If you want, the curve can be given like this. Suppose this is the line z. This is minus infinity. This is z. So we consider the whole area up to this. This is capital F of z. Okay. Sometimes the graph will be given and you are asked to identify. Here it is from, look at here, the lower limit is minus infinity. And what is the upper limit here? Z. So integral minus infinity to z. And look at the curve. It is a normal distribution curve. 1 by root 2 pi e raised to minus z square by 2 into dz. It is otherwise denoted as, listen here, it is otherwise denoted as P of z less than small z. Up to z. Probability of the variable up to z. P of z, capital Z less than small z. Okay. capital Z less than small z. Okay, we have learned about integration. Integration means what you have learned? Lower upper limit minus lower limit. Is or no? Integration. When we integrate, upper limit minus lower limit. So this is the first property. F of Z is given by this. By the definition, this is the format. From curve, this is one. And what is about the probability? Now, second one. Up to this, is it clear? Up to this, is it okay? Now the next one. The second one is, suppose we want to find the probability, we want to find the area included between the region Z1 and Z2. Okay, we want to find it, the region between Z1 and Z2. So we can write this as integral Z1 to Z2 e raised 1 by 2 pi 1 by root 2 pi e raised to minus z square by 2 into f of z into dz. Okay, so the same thing we can write this as capital F of z2 minus capital F of z1. Okay, we want to find the region like this. Suppose this is the curve. Suppose this is a line given by Z1. Z is equal to Z1. And this is a line Z is equal to Z2. So we want only those region. We want only this part. Then what do you have to do? We have to consider lower limit is Z1, upper limit is Z2. So we can write this as integral Z1 to Z2, 1 by root 2 pi e raised to minus z square by 2 into dz. So which will be same as f of z2 minus f of z1. Here we write capital F. Capital F means cumulative, adding. Capital F means summation. Next one. We know that sum of all probabilities is 1, isn't it? Sum of all probabilities is 1. Minus infinity to infinity. F of z into dz is 1. So, okay, area under the curve. Total area will be always 1. So what will be, okay, so we are going to learn about the complementary. Earlier we are, okay, in binomial also we have discussed this part. Now look at the third one. What is P of z greater than or equal to z1? Probability of z greater than or equal to. Both we can, or if it is equal to also, we take this as greater than. P of z greater than z1 will be same as 1 minus P of z less than or equal to z1. It is 1 minus P of z less than or equal to z1, which is same as 1 minus f of z1, which is same as 1 minus f of z1. For example, listen children, look at the curve. Suppose the curve is like this. Okay, and suppose here it is the point z is equal to z1. We want to find the area of this part. Area of this part. So what you can do? From the total, from minus infinity, okay, total area is 1. From the total, you subtract this part. From the total, if you subtract this part, will you be getting z is equal to z1? So, f of z is greater than z1 is same as 1 minus p of z less than or equal to z1. That is same as 1 minus f of z. So we can convert any normal distribution to standard normal distribution by substituting x minus mu by sigma is equal to z. X minus mu by sigma is equal to z. So next, again, few more properties. Properties of capital F of z, cumulative functions. Properties of cumulative function, F of z. Properties of cumulative function of z. So first property is f of infinity. What is f of infinity? Integral minus infinity to infinity. Full area we are considering 1 by 2 pi e raised to minus z square by 2 into dz will be always 1. F of infinity is 1. Total area. That means we consider the full area. So can you tell me what will be f of 0? What will be f of 0? What can you guess the answer? What will be f of 0? Okay, when you draw the curve, look at here, it is a bell-shaped curve. So this is the line. Okay, mu is here 0. So can you guess what is the area? F of 0? Full area is 1. And we know that it is symmetrical about the line x is equal to mu. So can you guess what is f of 0? What will be f of 0? Aishwarya? Yes?
0 itself.
0, its full area is 1, isn't it? We take this line. So what will be A up to this part? What will be the area up to this part?
Half.
Half. It is 0.5. Is it clear? It is symmetrical. It is symmetric. Symmetric means it is divided into 2 equal parts. X is equal to mu divides it into 2 equal parts. So if you take this line, half the line, what will be f of 0? What is the meaning of f of 0? Integral minus infinity to 0. 1 by root 2 pi e raised to minus z square by 2 into dz. It will be 0.5. If you take only half of it, it will be 0.5. Then the third property, f of minus z. F of minus z will be same as, okay, negative values. F of negative z will be same as 1 minus f of z. F of negative z will be same as 1 minus f of z. Sorry. F of minus z is 1 minus f of z. Okay, so the next is remark. Remark. You copied up to this. Shubham, is it okay? Shubham, Aparna? Up to this point, is it clear?
Yes, ma'am.
So write down the next one as remark. P of x less than or equal to A will be same as P of x less than A. If it is less than or equal to, in both the cases, the probability will be same. Similarly, P of x greater than A will be same as P of x greater than or equal to A. Okay, similarly, P of A less than x less than B will be equivalent to P of A less than or equal to x less than B, which is same as P of A less than x less than or equal to B, which is same as P of A less than or equal to x less than or equal to B. That means if you include that one also, probability will not change. In all the cases, the probability will be same. So for finding this probability, Z probability, there is a table. Hope you are all having the textbook. Take your textbook. In your textbook, the table is given there. In page number 548. Open your textbook, look at the table. So using this table, can you say this table? Okay. For taking the probability distribution, we use this table. Okay, we use this table. Are you all having the textbook? One side you have positive values, the other side you have negative values. Okay, only up to page number 548 and 549. Don't look into the table 550. That is for the next term. 549 and 548. Okay, write the next question. Write a question. Okay, Aparna. Okay. Write the question. Okay, so we are going to, using the table, let us see how to find out the probability value. Okay. So what is P of Z less than 1.5? What is P of Z less than 1.5? How will you take this? P of Z less than 1.5. Okay. Probability of Z less than 1.5 means same as F of 1.5. Okay. It is same as F of 1.5. Now use the table. Use the table given there. F of 1.5. What is the value? Look at the value from the table. What is F of 1.5? See, in one side you will have like this 0.1, 0.2, and the other side you have 0.01, 0.02 like that. So F of 1.5 means here you take 1. Here you take 1. 1.0, and here you take 0.05. 1 and 0.05. What is the value? Aparna, what is 1.5?
Yes, ma'am.
Now, can you give the value? F of 1.5. Okay, children, with this we wind up. We can use the table and we can do the problems in the next period. One more period we have, last period. Last period we can learn how, okay, we can learn how to use the table, how to write the values and all. Okay, with this I end the session now. Thank you.